Hello friends, in today's question, a transverse sinusoidal wave moves along a string in the positive x direction at a speed of 10 centimeter per second. The wavelength of the wave is 0.5 meter and its amplitude is 10 centimeter. At a particular time t, the snapshot of the wave is shown in the figure. The velocity of point P when its displacement is 5 centimeter is given by. So we have the snapshot and point P is given on the positive half cycle and at the falling, you can say, slope of this positive half cycle. So in this case, the question is given that it's a transverse sinusoidal wave. So in case of transverse sinusoidal wave, the particle displacement and velocity is perpendicular to the direction of propagation. And the direction of propagation is along x-axis. So as we know that your iota direction represents your x-axis and j represent our y-axis. So at least from this basic thing we can just say that option C and option D cannot be one of the correct options rather, because it is in I direction, which is your x-axis. So we are only to find out of A and B which will be the correct option. So we are going to start from the equation of the transverse wave, and the equation of the transverse wave excuse me, the equation of the transverse wave it is given as y of x comma t is equal to sine of kx minus omega t and plus phi. Let us call this equation number 1. And here y of x comma t is our displacement of the wave at position x and time t. So we have y of x comma t, displacement of the wave at position x and time t, at position x and time t. A is the amplitude of the wave, A is the amplitude of the wave, and k is our wave number, omega is our angular frequency, and finally we are left with phi, and that is a phase difference. Now we are supposed to find out the velocity at point P, and that will be the partial derivative of this equation number 1 with respect to time. So we can say velocity at point P, let us call that as Vy, Vy will be equal to partial derivative of y with respect to time t, and this gives us minus a omega, and we have cos of kx minus omega t and plus phi. And we are going to find out what will be the value of this function cos. So we can write that the cos function kx minus omega t plus phi, it can be written as cos square kx minus omega t plus phi square root, and with the trigonometric identity we can write it as 1 minus sine square kx minus omega t plus phi and its square root. Now we are going to find out the value of the sine function. For this we are going to use equation number 1. So we write from equation 1, the amplitude is, the position is given as 5, so we can write it as 5. This value of amplitude is given as 10, and we have sine of kx minus omega t plus phi. This gives us that sine of kx minus omega t plus phi will be equal to 0.5. Now we are going to use, let us call this as equation number 2. Substitute it in equation number 2. So from equation 2, we get cos of omega t, cos of kx. Cos of kx minus omega t plus phi will be equal to 1 minus 0.5 whole square root, and this comes as square root of 0.75 and will be approximately equal to 0.866. So we got the value of the function kx minus omega t plus phi. Now this function is going to have, forgot to mention that it will be plus minus. Now we have to choose whether the cos is going to have a plus value or minus value. Okay. So we say choosing the sign of cos function. Choosing the sign of cos function. In the figure, let me draw it here approximately. So this is our positive half cycle, and point P is given somewhere here. So we can say that point P is given the downslope of the first positive half cycle. Point P is given on the downslope of first positive half cycle. Therefore, cos function will have a negative sign. will have a negative sign. Therefore, cos of kx minus omega t plus phi will be equal to minus of 0.866. And in the options that are given, there is fractional form. So we can write this as approximately equal to minus square root of 3 divided by 2. Now we simply put the rest of the values. We know that v of y, it came as minus a omega cos of kx minus omega t plus phi. So we know all the values. Amplitude is given to us as 1 by 10 and omega will be equal to our 2 pi f, k multiplied by, let me calculate here omega. So omega will be equal to k multiplied by v, and the velocity is given, and k is our 2 pi upon lambda multiplied by v. So this gives us that omega will be equal to 0.4 times p. So we substitute it here. We get this as 4 upon 10 times pi minus square root of 3 divided by 2. So this gives us that v of y will be equal to positive square root of 3 pi divided by 50. Okay. And we already concluded at the start that this will be in the j unit direction. So this is the velocity of the particle. Now we can also calculate this velocity by using a direct formula which is based on that is phase velocity. That is Vp will be equal to omega a square minus x square. We can use that formula and find out the velocity. So let us try that also. So we can say using, you can say second method. And in second method, we can use the equation that particle velocity at point P is equal to omega square root of a square minus x square. Here a is given to us as 10 centimeter, which is nothing but our 0.1 meter, and the displacement x is our 5 centimeter, which can be written as 0.05 meters, and omega is the angular frequency. So we can say our omega is equal to 2 pi v divided by lambda. So we substitute, we get that our Vp is equal to 2 pi v upon lambda square root of a square minus x square. Square minus x square, and wave velocity, that is v is our wave velocity, and it is given as 10 centimeter per second, so which will be 0.1 meter per second. Lambda is our 0.5 meters. So we substitute all the values, we get that the velocity of the particle at point P will be equal to 2 pi multiplied by 0.1 divided by 0.5 square root of 0.1 whole square minus 0.05 whole square. And this can be written as 2 upon 5 pi and this will be equal to square root of 0.01 minus 0.025. Now it is simple calculation. 2 upon 5 pi and we get square root of 0.0075 and this comes as square root of 3 pi upon 50. So this gives us magnitude, and we can write that since the direction of point P is towards point P is towards the positive y-axis, the velocity can be written as in vector form as Vp is equal to square root of 3 divided by 50 pi, and this is our J unit vector. Okay. So in both the cases, both methods, we are going to get the same result. So if we check the options that are given to us, we can say option number A is the correct option. So you can say option A is correct. So this completes the question. By using both the methods, we got the same answer.